The microbiome is the collection of all microbes, such as bacteria, fungi, viruses, and their genes, that naturally live on our bodies and inside us. Although microbes are so small that they require a microscope to see them, they contribute in big ways to human health and wellness. They protect us against pathogens, help our immune system develop, and enable us to digest food to produce energy. Because the microbiome is a key interface between the body and the environment, these microbes can affect health in many ways and can even affect how we respond to certain environmental substances. Some microbes alter environmental substances in ways that make them more toxic, while others act as a buffer and make environmental substances less harmful. How can the microbiome affect health? The critical role of the microbiome is not surprising when considering that there are as many microbes as there are human cells in the body. The human microbiome is diverse, and each body site, for example, the gut, skin, and oral and nasal cavities, has a different community of microbes. A person's core microbiome is formed in the first years of life but can change over time in response to different factors including diet, medications, and environmental exposures. Differences in the microbiome may lead to different health effects from environmental exposures and may also help determine individual susceptibility to certain illnesses. Environmental exposures can also disrupt a person's microbiome in ways that could increase the likelihood of developing conditions such as diabetes, obesity, cardiovascular and neurological diseases, allergies, and inflammatory bowel disease. For example, specific changes in the gut microbiome have been linked to liver health. NICE-funded researchers and collaborators developed a rapid, low-cost tool that uses stool samples to detect microbial changes that can accurately diagnose liver fibrosis and cirrhosis. What is NICE doing? NICE studies the microbiome to gain a better understanding of its complex relationships with the environment, and how these interactions may contribute to human well-being or disease. This knowledge could help us revolutionize the way new chemicals are tested for toxicity, and design prevention and treatment strategies for diseases that have environmental causes. As part of efforts to implement the NIEHS strategic plan, a cross-divisional faculty was created with the goal of fostering collaborative research on the microbiome across the NIEHS Division of Intramural Research, Division of Translational Toxicology, and Division of Extramural Research and Training. NICE-supported research related to the microbiome includes a variety of environmental factors, including air pollution. NICE-funded research found breathing ultrafine particles, a component of air pollution, altered the gut microbiome and changed lipid metabolism in mice with atherosclerosis. Another study showed that exposure to traffic-related air pollution, TRAP, altered the respiratory microbiome in children. Antimicrobials, a study found a profound effect from triclosan, a common ingredient in antimicrobial products, on the gut microbiome in mice. Mice that consumed triclosan through drinking water displayed an uptick in bacterial genes related to the stress response, antibiotic resistance, and heavy metal resistance. Artificial sweeteners, sucralose, an artificial sweetener, changes the gut microbiome in mice and may increase the risk of developing chronic inflammation. Another study found acesulfame potassium, also an artificial sweetener, induced weight gain in male, but not female, mice. Chronic stress disturbs the gut microbiome in mice, triggering an immune response and promoting the development of colitis, a chronic digestive disease characterized by inflammation of the inner lining of the colon. Diet. NICE researchers showed a high-fat diet affected the gut microbiome of mice in a way that predisposed them to gain weight and develop obesity. Flame retardants. Early life exposure to types of flame retardants called polybrominated diphenyl ethers, PBDEs, and polychlorinated biphenyls, PCBs, can have a lifelong impact on disease risk, which may be shaped by the gut microbiome. Heavy metals. Arsenic exposure in mice changed the gut microbiome and altered molecular pathways in bacteria that are important to biological functions like DNA repair. A separate study suggested that the microbiome could protect mice from arsenic or methylmercury toxicity. In addition, research in a mouse model of Alzheimer's disease demonstrated that exposure to cadmium altered an important communication pathway between the gut microbiome and the central nervous system, called the gut-brain axis. Infant health, birth mode, by C-section or natural birth, and what is eaten, formula or breast milk, during the first 6 weeks of life may affect the type of microbes in the gut microbiome of infants. The composition of the vaginal microbiome at birth can have lasting effects on offspring metabolism, immunity, and the brain. Pathogens, certain microbes, or pathogens, in the human oral microbiome may play a role in either increased or decreased risk of pancreatic cancer. Pesticides, exposure to the widely used agricultural insecticide diazinon changed the gut microbiome of mice. These changes were more pronounced in male than female mice, providing insight into previously reported sex-specific effects of this toxicant on the nervous system. What questions remain about the microbiome? Research has yielded tremendous insight into the links between the microbiome, environmental exposures, and human health. Yet big questions remain and are the focus of continuing research supported by NIEHS. These questions include: what are the associations between biological responses to exposures and the microbiome? What information about the microbiome should be collected to understand how the microbiome responds to environmental exposures? In what ways does the microbiome affect exposure to toxic chemicals? Are current tools for manipulating the microbiome sufficient to develop interventions to prevent disease? Acrylamide is a chemical widely used during the manufacturing of paper, dye, and other industrial products. It can also be formed when certain foods are cooked at high temperatures. Frying, baking, or roasting certain foods, such as potatoes or grains, can create acrylamide. French fries and potato chips, for example, may have measurable acrylamide levels. Acrylamide is also found in cigarette smoke. How do people get exposed to acrylamide? Food and cigarette smoke are the major sources of acrylamide exposure. How does acrylamide get into foods? When certain foods are cooked at high temperatures, sugars, such as glucose and fructose, can react with the free amino acid, asparagine, to form acrylamide. Acrylamide forms as part of a chemical reaction, known as the Maillard reaction, which contributes to the aroma, taste, and color of cooked foods. Acrylamide is one of the hundreds of chemicals that can form during the Maillard reaction. Are acrylamide levels regulated? The U.S. Food and Drug Administration, FDA, is currently developing guidance for industry on reduction of acrylamide levels in food products. FDA also regulates the amount of acrylamide in a variety of materials that come in contact with food. The U.S. Environmental Protection Agency, EPA, regulates acrylamide levels in drinking water. How can I reduce my family's exposure to acrylamide? Adopt a healthy, balanced eating plan that includes fruits and vegetables, lean meats, fish, high-fiber grains, and beans. Other tips: fry foods at 170 degrees Celsius, 338 degrees Fahrenheit, or lower. Cook potato strips, such as French fries, to a golden yellow rather than a golden brown color. Toast bread to the lightest color acceptable. Soak raw potato slices in water for 15 to 30 minutes before frying or roasting. Drain and blot dry before cooking. Do not store raw potatoes in the refrigerator. Why did the National Toxicology Program (NTP) study acrylamide? The nomination to study acrylamide came from the FDA. The FDA wanted high-quality data from animal studies to help support risk assessments to understand any potential risks to humans. Acrylamide has been previously shown to cause several types of cancer in animals, but more information was needed to better understand how acrylamide causes tumors and at what doses the tumors occurred in animals. National Toxicology Program (NTP) also conducted studies on glicidamide, the major metabolite of acrylamide. When acrylamide is consumed through food, the body converts it to glicidamide. Since this conversion may differ among rodent species, comparing the effects of acrylamide and glicidamide in rats and mice provides meaningful support for human health risk assessments. The NTP studies on acrylamide and glicidamide were conducted at the FDA National Center for Toxicological Research (NCTR), as part of an interagency collaboration between NIES and FDA/NCTR. What did the NTP studies find? The 2-year NTP studies of acrylamide, given in an animal's drinking water, found clear evidence of carcinogenic activity in male and female rats and mice, based on tumors in multiple sites. For example, tumors were found in the mammary and thyroid glands in female rats, and the reproductive organs in male rats. Tumors of the lung were among those observed in mice. Additionally, NTP conducted parallel studies on glicidamide, which was also found to be a multi-site carcinogen in both male and female rats and mice. The types of tumors induced by glicidamide were the same as those seen in acrylamide. Findings of clear evidence of carcinogenic activity in both sexes of rats and mice, and at multiple sites, is relatively uncommon and indicative of a strong carcinogenic response. Air pollution is a familiar environmental health hazard. We know what we're looking at when brown haze settles over a city, exhaust billows across a busy highway, or a plume rises from a smokestack. Some air pollution is not seen, but its pungent smell alerts you. It is a major threat to global health and prosperity. Air pollution, in all forms, is responsible for more than 6.5 million deaths each year globally, a number that has increased over the past 2 decades. What is air pollution? Air pollution is a mix of hazardous substances from both human-made and natural sources. Vehicle emissions, fuel oils and natural gas to heat homes, byproducts of manufacturing and power generation, particularly coal-fueled power plants, and fumes from chemical production are the primary sources of human-made air pollution. Nature releases hazardous substances into the air, such as smoke from wildfires, which are often caused by people, ash and gases from volcanic eruptions, and gases, like methane, which are emitted from decomposing organic matter in soils. Traffic-related air pollution, TRAP, a mixture of gases and particles, has most of the elements of human-made air pollution: ground-level ozone, various forms of carbon, nitrogen oxides, sulfur oxides, volatile organic compounds, polycyclic aromatic hydrocarbons, and fine particulate matter. Ozone, an atmospheric gas, is often called smog when at ground level. It is created when pollutants emitted by cars, power plants, industrial boilers, refineries, and other sources chemically react in the presence of sunlight. Noxious gases, which include carbon dioxide, carbon monoxide, nitrogen oxides, NOx, and sulfur oxides, SOx, are components of motor vehicle emissions and byproducts of industrial processes. EPA pollution. Image courtesy of EPA. Particulate matter, PM, is composed of chemicals such as sulfates, nitrates, carbon, or mineral dusts. Vehicle and industrial emissions from fossil fuel combustion, cigarette smoke, and burning organic matter, such as wildfires, all contain PM. A subset of PM, fine particulate matter, PM 2.5, is 30 times thinner than a human hair. It can be inhaled deeply into lung tissue and contribute to serious health problems. PM 2.5 accounts for most health effects due to air pollution in the U.S. Volatile organic compounds, VOC, vaporize at or near room temperature, hence, the designation volatile. They are called organic because they contain carbon. VOCs are given off by paints, cleaning supplies, pesticides, some furnishings, and even craft materials like glue. Gasoline and natural gas are major sources of VOCs, which are released during combustion. Polycyclic aromatic hydrocarbons, PAH, are organic compounds containing carbon and hydrogen. Of more than 100 PAHs known to be widespread in the environment, 15 are listed in the report on carcinogens. In addition to combustion, many industrial processes, such as iron, steel, and rubber product manufacturing, as well as power generation, also produce PAHs as a byproduct. PAHs are also found in particulate matter. Air pollution and climate change. Air pollution and climate change affect each other through complex interactions in the atmosphere. Air pollution is intricately linked with climate change because both problems come largely from the same sources, such as emissions from burning fossil fuels. Both are threats to people's health and the environment worldwide. Read more: Health Impacts of Air Quality. What is NIEHS doing? Over its 50-plus-year history, NIEHS has been a leader in air pollution research. The Institute continues to fund and conduct research into how air pollution affects health and the population groups who are most affected. How does air pollution affect our health? When the National Ambient Air Quality Standards were established in 1970, air pollution was regarded primarily as a threat to respiratory health. In 1993, NIEHS researchers published the landmark Six Cities study, which established an association between fine particulate matter and mortality. Air pollution exposure is associated with oxidative stress and inflammation in human cells, which may lay a foundation for chronic diseases and cancer. In 2013, the International Agency for Research on Cancer of the World Health Organization, WHO, classified air pollution as a human carcinogen. Research on air pollution and health effects continually advances. Public health concern now includes cancer, cardiovascular disease, respiratory diseases, diabetes mellitus, obesity, and reproductive, neurological, and immune system disorders. Cancer. A large study of more than 57,000 women found living near major roadways may increase a woman's risk for breast cancer. The NIEHS sister study found other airborne toxic substances, especially methylene chloride, which is used in aerosol products and paint removers, are also associated with increased risk of breast cancer. Occupational exposure to benzene, an industrial chemical and component of gasoline, can cause leukemia and is associated with non-Hodgkin's lymphoma. A long-term study, 2000 to 2016, found an association between lung cancer incidence and increased reliance on coal for energy generation. Cardiovascular disease. Fine particulate matter can impair blood vessel function and speed up calcification in arteries. NIEHS researchers established links between short-term daily exposure by postmenopausal women to nitrogen oxides and increased risk of hemorrhagic stroke. For some older Americans, exposure to TRAP can result in lowered levels of high-density lipoprotein, sometimes called good cholesterol, increasing their risk for cardiovascular disease. According to a National Toxicology Program (NTP) report, TRAP exposure also increases a pregnant woman's risk for dangerous changes in blood pressure, known as hypertensive disorders, which are a leading cause of preterm birth, low birth weight, and maternal and fetal illness and death. Respiratory disease. Air pollution can affect lung development and is implicated in the development of emphysema, asthma, and other respiratory diseases, such as chronic obstructive pulmonary disease, COPD. Increases in asthma prevalence and severity are linked to urbanization and outdoor air pollution. Children living in low-income urban areas tend to have more asthma cases than others. Research published in 2023 tied two air pollutants, ozone and PM2.5, to asthma-related changes in children's airways. PM and nitrogen oxide are linked to chronic bronchitis. In 2020, a major public health challenge was confluence of the COVID-19 pandemic and wildfires across the western U.S. building on a well-established connection between air pollution and respiratory tract infections. A study linked wildfire smoke with additional COVID-19 cases and deaths. Whom does air pollution affect the most? Air pollution affects everyone's health, but certain groups may be harmed more. Almost 9 out of 10 people who live in urban areas worldwide are affected by air pollution. Children. The NIH-funded Children's Health Study at the University of Southern California is one of the largest studies of the long-term effects of air pollution on children's respiratory health. Among its findings, higher air pollution levels increase short-term respiratory infections, which lead to more school absences. Children who play several outdoor sports and live in high-ozone communities are more likely to develop asthma. Children living near busy roads are at increased risk for asthma. Children with asthma who were exposed to high levels of air pollutants were more likely to develop bronchitis symptoms. Living in communities with higher pollution levels can cause lung damage. Other studies on women and children. NICE-funded researchers from the University of California, Davis Environmental Health Sciences Center are conducting the Biospecimen and Fire Effects, Be Safe, study. This ongoing project seeks to discover if and how recent wildfires and their smoke affected pregnant women and their babies. Begun in 2017, study participants are pregnant women who were living in Northern California when the 2018, 2019, or 2020 wildfires occurred there. Breathing PM 2.5, even at relatively low levels, may alter the size of a child's developing brain, which may ultimately increase the risk for cognitive and emotional problems later in adolescence. Prenatal exposure to PAHs was associated with brain development effects, slower processing speed, attention deficit and hyperactivity disorder, ADHD, symptoms, and other neurobehavioral problems in urban youth. In New York City, prenatal exposure to air pollution may play a role in childhood ADHD-related behavior problems. Prenatal exposure to particulate matter was associated with low birth weight. Women exposed to high levels of fine particulate matter during pregnancy, particularly in the third trimester, may have up to twice the risk of having a child with autism. Second and third trimester exposure to PM 2.5 might increase the chance of those children having high blood pressure in early life. In California's agricultural San Joaquin Valley, women who were exposed to high levels of carbon monoxide, nitrogen oxide, or nitrogen dioxide during their first 8 weeks of pregnancy were more likely to have a baby with neural tube defects. In Marietta, Ohio, home to a ferromanganese refinery, manganese concentrations in blood and hair, a biomarker of air pollution exposure, were associated with lower child IQ scores. Older adults. Alzheimer's disease and related dementias are a public health challenge for aging populations. NICE-funded researchers at the University of Washington identified a link between air pollution and dementias. This well-conducted study adds considerable evidence that ambient air fine particles increase risk of dementias. Conversely, a multi-year study published in 2022 shows improved air quality is associated with lower risk of dementia in older women. The researchers also stated this decline in dementia risk was equivalent to taking nearly 2.5 years off the age of the women studied. Air pollution was linked to a greater chance of developing several neurological disorders, including Parkinson's disease, Alzheimer's disease, and other dementias. Hospital admissions data from 63 million older adults in the U.S., obtained over 17 years, 2000 to 2016, was analyzed along with estimated PM 2.5 concentrations by zip code to conduct the study. In older adults, long-term exposure to TRAP may significantly hasten physical disabilities. The risk is more pronounced among racial minorities and lower-income people. Osteoporosis affects women more than men. A large study associated high levels of air pollutants with bone damage, particularly in the lumbar spine, among postmenopausal women. This study expands previous findings linking air pollution and bone damage. Nutrients may counter some harmful effects from air pollution. A 2020 study found omega-3 fatty acids, obtained by eating certain fish, may protect against PM 2.5 associated brain shrinkage in older women. Rural dwellers. An NIEHS-funded study found that concentrations of PM 2.5 in rural Washington state were comparable to urban Seattle. In this study, as regional PM 2.5 increased, there were increased asthma symptoms, such as limitation of activities, more wheezing, and more nighttime waking, in rural children. In the rural U.S., large-scale animal feeding operations might compromise regional air quality through emission of pollutants, such as ammonia gas. A study found acute lung function problems in children with asthma in such areas. Different genes. Your genes play a role in respiratory health. NIEHS-funded research discovered that people with specific gene variants, which made them more likely to have lung inflammation, had a greater chance of suffering from asthma if they lived close to major roadways. NIEHS and community involvement. NIEHS supports community participation in the research process and encourages collaborative approaches that build capacity in communities to address environmental health concerns. Community-engaged research and citizen science are two types of collaborative research approaches. For example, NIEHS helps residents of Imperial County, California track air pollution through a network of 40 community-run monitors. In this county, long-term improvements in air quality were associated with significant lung function improvement in children. In another example, NIEHS grant recipients developed community-level tactics and public policies for reducing exposure to TRAP. Using high-efficiency particulate air (HEPA) filtration. Building land use buffers and vegetation barriers. Improving urban design with gardens, parks, and streetside trees. Creating active travel options, such as bicycling and walking paths. The Trade, Health, Environment, Impact Project brings together researchers and community groups to find solutions for communities affected by trade-related pollution, such as ports and roadways, with trucking. Join an asthma study. The goal of the Natural History of Asthma with Longitudinal Environmental Sampling (NAILS) study is to help scientists understand how bacteria and other factors in the environment affect people who have moderate to severe asthma. Who can participate? Moderate to severe asthmatics. Males and females aged 18 to 60. Females should not be pregnant or breastfeeding at the start of the study, but may still participate if they become pregnant during the study. Non-smokers who are also not around significant amounts of secondhand smoke. No history of chronic obstructive pulmonary disease, emphysema, cystic fibrosis, CF, pulmonary fibrosis, non-CF bronchiectasis, sarcoidosis, unstable angina, or pulmonary hypertension. Not allergic to methacholine. Able to provide your own transportation to clinic visits on the NIEHS campus in North Carolina. For more information about this study. NAILS, Asthma Study. Tel 855 MYNIEHS, 855-696-4347. nails@mail.nih.gov. Why improving air quality matters. Air pollution and birth outcomes are linked as global public health concerns. Researchers analyzed indoor and outdoor air pollution data from all inhabited continents along with key pregnancy outcomes. Their findings indicate efforts to reduce PM 2.5 exposure could lead to significant reductions in the number of low birth weight and preterm birth infants worldwide. Air pollution reduction would be especially beneficial for children born in low- and middle-income countries. Among children in Southern California, decreases in ambient nitrogen dioxide and PM 2.5 were associated with fewer cases of asthma. An NIEHS-funded study found that a mixture of several B vitamins may protect DNA from changes attributable to PM 2.5 air pollution. Bronchitis symptoms declined as pollution levels dropped in the Los Angeles region. Improving air quality may improve cognitive function and reduce dementia risk, according to studies supported in part by NIH and the Alzheimer's Association. When fossil fuel power plants close, nearby air pollution is reduced. A study found the incidence of preterm births went down within 5 kilometers of retired coal and oil-powered plant locations.